Right, do you guys mind if I do a selfie?
Do a selfie.
Do a... Currently we're down at the Xtreme Everest team's altitude laboratory down in London, and you can see behind me is we've got like 12% oxygen in here. So this altitude chamber simulates being at a high altitude, 4,500 meters in here. I'm getting my blood taken. We're doing lots of pretty cool experiments on hypoxia and how the body deals with that lack of oxygen.
The difficulty is, the advantage of going to altitude, taking all subjects to altitude, is that you can take a lot of people up. And even though it doesn't necessarily seem like this is actually quite a cheap way of doing it, because you've got the hypoxic environment, but there's lots and lots of variables. Temperature is a big one, equipment failure. The logistically it's quite difficult. So it's actually, from a more scientific point of view, it's better to do it in a controlled environment like the room we're in at the moment. So one of the aspects we're looking at in this experiment is we're looking at the microcirculation. Microcirculation under your tongue is actually a really good reflection of the central circulation, so we've got a good idea of what's happening within your brain and the flow of blood. So what we do is we do an baseline experiment outside, and that's at 0 hour, and then we bring you into this hypoxic environment at 12%, and then we do experiments every 2 hours. This involves putting in an HD microscope under your tongue. As you know now, you have to stay very still, and I have to stay very still, it's a little bit difficult. And what we're looking at there is essentially the blood flow, the amount of blood that's going through those blood vessels, okay, and see whether that's changed in response to the hypoxic environment. We want to know whether it's changing, we also want to know whether it's changing and constantly changing, or it's just there's one speed outside, and then when you come inside there's a different speed. Because obviously the oxygen environment is staying the same.
It's kind of like measuring the speed of cars on the track.
Yeah, it looks a little bit like scale electrics, especially when you see white blood cells zooming around.
Yeah. And you know, the guys and girls down here at Xtreme Everest are amazing. Looking after me today, Joel, Tom and Amy. Amy's actually doing the experiment as well, so she's been having her blood tested at the moment. She's just finished, I've got another hour left in, and then I get my blood tested as well.
I've been looking at how your blood moves, how quickly it moves, and when it gets to tissues, how quickly is the oxygen being used up. So I was looking at how your oxygen was being consumed by your tissues, and to do so I was using basically a wavelength of light which is really close to infrared radiation but gets mixed up by visible light, so I was trying to keep your arm in the dark. I was using lasers and the Doppler shift that you might see in a sort of a passing vehicle to measure speed. And I used a compression cuff to shot off blood flow to your arm and then release it, so that looked at changes to how your blood was flowing and also how your tissues were using oxygen without blood flow.
When you've only got 12% oxygen in the room and you've been in there all day, it gets hard to kind of concentrate on stuff and hold conversations. I've actually had to put this in my emails because, you know, so many times people come out of here and they've like messed up emails and they make no sense whatsoever. So I just put them in an altitude chamber. If it doesn't make sense, please let me know. So I apologise to anyone who did hear from me today and I don't make any sense whatsoever.
And then the final experiment that we're doing, also is why we took your blood at the beginning, and I'll take it again in a minute, is because people are not really sure what happens to your coagulation when exposed to hypoxia. When you take someone to altitude, they have an increased incidence of DVTs and PEs, so your blood is, you would have thought, be more viscous, more likely to clot. However, there's several confounding factors. One being the fact that as you go to altitude and you adapt, you create more red blood cells, so your hematocrit goes up. So your blood becomes more gloopy and therefore it's more likely to clot. That's something different to the coagulation cascade. In blood tests that have been done at altitude, it does kind of suggest that you're less likely to clot at altitude, which obviously goes against what we're seeing in patients and things like that. So what we're doing is we're taking a blood test at the beginning, and then we're going to compare that to a blood test 8 hours later. And the machine we're using is called TEG, which stands for thromboelastograph, and it creates another nice little graph, and it gives us really useful information. This is only used in intensive care units, in specialist intensive care units around the UK, for transplant patients and patients who've had severe hemorrhage, because it gives you a little bit more information than a normal blood coagulation test. But it looks at the speed that it takes your blood for the initiation of coagulation to start. Then it looks how quickly it takes for the clot to form, and then at the end, it's the reason we run the test for an hour. We look at how strong the clot is, and so we're going to see whether there's any change. And from our point of view, it'll be interesting to see if there's no change. That's also interesting because that kind of rules out something else. Because you'd worry that if there is a change, the problem is that patients that are in a hypoxic environment, or they are suffering from hypoxia in hospital, then that's kind of altering their coagulation, which would be a problem, which probably then warrants further investigation.
So hopefully for me this will mean, I know a little bit about what I'm like at altitude, and going from sea level to altitude really quickly as well. So that'll mean that I feel more comfortable in the mountains, especially going to altitude. So lots of good experiments, lots of good results from today.
What we're trying to do here, the whole point of all of this stuff is not so that someone can know whether they're going to climb a mountain and code better up at altitude. We personally don't really care about that so much. The important thing is how can we better understand what's happening to the human body when they are hypoxic. So patients in the hospital in the ITU have got a low blood oxygen level. How is that affecting them? And if we know what it's doing to them, we can then try and address that and try and reverse that. Is it like the EastEnders for Wales?
Yeah, that's
Better.
exactly it. But it's a bit better than that actually, because it's slightly more realistic. People are getting driven into all the time by big vans.